get into the big topic of open source, something that we actually say.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin live stream. We are here, and you'll notice that I don't have my usual co-host with me. Johnny is on some well-earned PTO this week, but I do have our guest, Mr. Franck Baudin, joining us today. So if you happen to miss the title of this particular episode or the subject, we're going to be talking about the Performance Addon Operator. So we'll get into much more details there. This is this one pokes all my nerd buttons. It makes me happy to be able to mess around. And when Frank and I were talking yesterday, it was it's this one's a little dangerous, right? You can break things, and when you break things, that's bad. But I'll quit talking about Frank, and I'll let Frank introduce himself if you don't mind.
Hi everyone. So I'm Franck Baudin, based out of France. I'm a technical product manager on OpenShift for telco and networking, and focus this year on the 5G core rollout, and with a lot of performance add-on operator.
Yeah, and I know the technical product manager aspect there is really important because you are one of our more technical product managers for sure, and I think that's something that is really good and really exciting to our audience here.
Let's see.
I know you're very modest about all of this. You keep telling me, oh, it's probably going to be a short subject. I'm not so sure because, like I said, this is one that's interesting to me. It's really, again, it pokes all of those buttons for me around all the stuff that I like to tune and adjust and make sure that everything is operating the best that it can. So we'll get to all of that in a few minutes. But first, let's do our normal top of mind topics. So first and foremost, this is one of our office hours series of live streams here with Red Hat Live Streaming, which means that if you've ever had a manager or a professor or anybody like that who had office hours, we're here to help answer your questions, whatever it is that is on your minds. If you have a question about OpenShift, about how it works, about something that's broken, maybe just what's the best way to do something, feel free to ask all those questions in chat. So it doesn't matter which one of the platforms you happen to be watching us on, whether it's one of the YouTube channels, whether it's Twitch, any of that stuff, all of that chat gets accumulated and it gets rebroadcast across all of the others. So by all means, go ahead and send us those messages and we'll address them as they come in. So with that being said, let's talk a little bit about the top of mind topics. And just as a reminder, these are things that Johnny and I have found or we think that might be interesting to you all that we discovered kind of since the last live stream that we did. So the first thing that I want to talk about here is going to be a blog post that was recently published. You can see it was published on Monday. And this is around Ansible and OpenShift integration. Let me go ahead and grab the link here and I'll put that onto Twitch as soon as I actually switch over to the live stream here in Twitch. There we go. So this blog post describes how to configure essentially OpenShift to act as an execution engine for, well, Ansible. So the really cool thing here is that, and if we scroll down, it goes through and talks about all the stuff, all the steps that you need to take. But the thing that I liked in here is we have like this graphic where I can have an Ansible job inside of Tower, and when it executes, when it launches, it's reaching out to OpenShift and it triggers a job inside of OpenShift to actually do that. So what this means is you're kind of, unblocking the scale of Ansible and Ansible Tower to unlimited. As many jobs as you need to run, as many concurrent jobs as you need to run, they can all be scheduled against a Kubernetes cluster or an OpenShift cluster so that you can, take care of those. So I thought this was really cool. It's something that's interesting, particularly as, we start to see more and more cross-infrastructure, cross-application integration happening within our customers and the applications that they're doing. I've seen and I've worked with a number of customers who they'll, hey, my application needs to deploy something or my application team needs to deploy something. And some of it is in OpenShift, and some of it is in virtual machines, and some of it is physical. And we need to reconfigure this. We need to provision storage off of that, and have everything mesh up in the end. So to me, this one was really cool and really exciting. But I won't. Hopefully, I won't oversell it. Let's see. Where's my notes document? The first one I forgot to bring up is that a reminder that there will be there will be no Ask an OpenShift admin live stream next week. So February the 16th, we will not have this live stream. However, there will be the What's New in OpenShift 4.10 presentation happening at the same time. So essentially, if you're not familiar, the Red Hat product management team has 2 live streams that they do basically every quarter. So one is What's New. It happens with each release of OpenShift, and it describes all of the new things that you'll find happening inside of that release. We typically schedule those for 90 minutes. I don't know that one has ever gone less than 90 minutes. Usually it's closer to 2 hours. They're really thorough. They're really good. The PM team does a phenomenal job of, listing out all the stuff that's happening inside of there. Typically, here on the Ask an OpenShift admin live stream, we'll follow up with that. And I like to pull out a couple of the things that I think are really important to you all and kind of dig down into them a little bit and explore what that means for us. So if you happen to be watching the live stream, feel free to, send me a message and let me know, hey, can you pull this apart? Can you dig into this? Also, while you're watching, be aware that there will be several of us, definitely me. I think Christian usually joins, Eric, who Eric does the gaming live stream and all that other stuff. So there'll be several of us here on the live stream to help answer questions. So if you have any questions, comments, etc., as they're going through that presentation, be sure to leave them here in the live stream. We always shuttle those over to the product management team. So if there's anything we can't answer, we can get those answers from them. And of course, they always like to know what your thoughts and opinions are too. Okay, so that being said, do subscribe to the channel if you haven't already, whatever platform you happen to be on. We do have a number of really interesting shows coming up towards the end of the month. So I don't have the list in front of me, so I don't remember off the top of my head what they are. I've been completely consumed with one of my tasks this week. I've so far, it's only Wednesday, and I've spent like 20 hours on this thing. So my brain is only half here. But yeah, do please get subscribed. If you don't want to subscribe on YouTube or on Twitch or anything like that, definitely check out. So it's red.ht/live streaming. That page, that's the landing page for Red Hat live streaming, that has the whole calendar of all of the live streams there. And it is a Google Calendar. So down in the lower right-hand corner, there's a little thing that says add to Google Calendar. So you can subscribe to the calendar there if you'd like. So that way you can get notified if we cancel. So for example, if you're subscribed to that calendar, you would see the canceled one for next week, as well as supplement your brain with fried turkey. That would not be a good idea, Tiger. The tryptophan would be counterproductive. Stephanie, thank you very helpfully. So hopefully we'll be talking about ODF Essentials. We might be doing a dive into that and what that looks like inside of clusters. I think there's some other 4.10 specific things that we wanted to call out as well. One of the ones I wanted to talk about is L3 mode with, so BGP mode with Metal LB. Inim State, yes, thank you. That's another good one. So I have a show scheduled. I don't have the guest lined up yet, but Inim State is going GA, we think. We should be going with 4.10. And there's some really cool stuff that'll be happening there at the installer level. So stay tuned for that. I'm not going to spoil the PM team surprise. All right. Moving on. We had, so internally, a lot of the Red Hat folks, particularly the ones that are close to the BU here and engineering, we had what we call the OpenShift Networking Summit last week. It's an internal thing, and we talk about all of the things that are happening with networking in OpenShift. And of course, one of the subjects that came up was, well, OVN Kubernetes versus OpenShift SDN. It's been talked about since we released OVN Kubernetes as a fully supported SDN option back in 4.6, I think, 4.6 or 4.7. Which one of these do I use? Which one should I choose? And really, it comes down to the default continues to be OpenShift SDN. And as of right now, there's no real, there is a goal, a longer term goal to change that from the default. I think if you remember, we had maybe a year ago, I don't think it was a year and a half, but about a year ago, we had Mark Curry on the live stream, and Mark had said, yeah, 4.9, we intend to switch the default to OVN Kubernetes. So that's been pushed out for a number of different reasons. The default continues to be OpenShift SDN. So my perspective, my personal opinion is continue to use the default unless you don't have a reason to. So if we share my screen here, in the documentation, we have this, what are the different features available? And you'll notice that OVN Kubernetes has a number of different things that it's capable of doing. So for example, IPsec encryption, IPv6, that OpenShift SDN isn't capable of. So if you don't need any of these features, OpenShift SDN as the default makes perfect sense. I'm going to post this link into the chat here. OpenShift SDN continues to make perfect sense. And the good news is you can migrate. So if you deploy OpenShift SDN today and you discover that you need OVN Kubernetes, you can migrate in between them. So you can see here in the documentation, the very next page is migrating. So today, right this moment, the only thing that, or the only thing that comes to mind that would prevent you from doing this migration is if you need features that can only be turned on at install time. And specifically what I'm thinking of here is the hybrid networking option that's required for Windows nodes and Windows containers. So that has to be turned on. It's basically an option when you do the install. It can't be turned on day two. However, I think I heard a rumor that that might be on the roadmap. So that would be one less reason why you shouldn't do the default today unless you know today that you want to use OVN Kubernetes. And then if the need arises in the future, you can always make that switch. Catching up on chat here. Please post the URL of the blog you're showing. Yep, I think we did that, but I'll go ahead and post it again just to be sure. So, and it's that ansible.com link that I just posted into chat. And aside from that, yeah, what about trip to Tahiti? Yeah, I wish that would be nice. I keep trying to convince my wife that we should go to that part of the world, and my wife is not a flyer. So while I have been to the APAC region multiple times, I've been to Australia and all of that a few times, and absolutely love it there. My wife is not on board with the 14, 15-hour plane ride to get there. Do you recommend using another CNI like Calico or Cilium? That again goes to what are your needs, what are your requirements. So Calico and Tigera is the company, and their open source or their community one is Calico Community, I think, or yeah. And then there's Calico Enterprise. If you need those features, if that fits with what your model is, with the things that you're doing, then yes, by all means, use Calico, use Cilium, right? Use whatever one happens to meet your needs. I have no preference between them. I know Calico offers a lot of really cool things. So like they do all layer 3 SDN. I think that's one of their options. So everything is routed. Everything is, there's not an SDN on an SDN or anything like that. If you happen to be using another SDN at the hypervisor level, stuff like that. So they also have some pretty powerful network policy stuff. We talked, was it 2 weeks ago, 3 weeks ago when we had the VMware folks on, we talked about the possibilities there with Antria and with NSX. Same sort of thing. You want to use those capabilities? Great. That's wonderful. It will absolutely work with OpenShift. It's certified. I think we have a whole certification program for that. So no harm in doing that. CNCF community had a webinar last night on using Submariner make services across clusters. Yep. So Submariner is, as far as I know, and I will be clear, I'm not the expert here, as far as I know, decoupled from the specific SDN. So essentially it creates a layer 3 overlay network between the clusters so that they can communicate, it's an SDN to SDN communication without having to route outside of the cluster, if that makes sense. It's not going through the egress ingress path. I'll put it that way. So Submariner is definitely a thing. It's integrated with ACM now. So if you create a cluster pool inside of ACM, you can then go in and tick the box and say deploy Submariner, and then it will deploy it across there. So I'll see if I can get some more details there. One of the things that we had talked about in the not too distant future was talking about service mesh. And I think that integrating in with all of that would be a great opportunity to talk about Submariner and some other various networking-y things. Depending on the scope of that or how large that topic is, we may even have a dedicated stream for it. So keep an eye out for that one. And of course, I always try and remind people of what our upcoming topics are when I'm paying attention to my own schedule ahead of time. So yeah, eBPF. Yeah, there's lots of really interesting stuff that's happening in that area. We should definitely have Mark Curry on. I'm going to take a note for that. All right. So the last thing that I wanted to talk about real quick here is OpenShift Commons. So if you're not familiar, OpenShift Commons is kind of our community set of stuff. So the Commons group regularly has these Commons gatherings where they talk about a bunch of different topics. This one just happened to pop up because Christian is a friend of mine and he's always telling me about GitOps things. But definitely, if you have some time, you can see it's right when our stream ends. You can hop over to hop in, no pun intended, and watch their event that's going on there. I'll go ahead and post the link to this. So I'm sure that there'll be lots of good information here. I actually haven't looked at the schedule myself. Yeah, so Christian's actually participating. That's probably why he was harassing me about it. So yeah, lots of really good and interesting stuff. Christian, who I was just helping him review a chapter for his upcoming GitOps book. So there is just a ton of stuff. And if you're not familiar with GitOps, it's definitely something that I am encouraging everybody to get familiar with now. You remember last week when we had the validated patterns team on, remember all of their stuff is driven through GitOps. So it's just becoming more and more prominent. And I've been doing a lot of work this week with ACM, right? ACM, we can leverage GitOps in order to deploy applications across, clusters as they're joining, not just applications, but features of OpenShift. So it's really interesting. There's a lot of power behind that, and it's only getting better as time goes on. So I guess this time I have to send Christian the check because I'm the fanboy, as it were. Tiger, I'm a flyer. Yeah, I know, Tiger, you live. I know you were here in Raleigh for a while, but you actually live on the other side of the world. So, any other comments here? I don't think so. So I think that's all of the top of mind topics. Oh no, I missed one. So there's a question internally that came in, which is it possible to disable the metrics service? The person was specifically asking about Prometheus, but really it's the metrics service broadly. And the answer to that is sort of. So I brought up the documentation page here, which is, and the important thing here is we can effectively set the operator to be unmanaged and then basically have it uninstall all of those components. It's not a supported option. It's not a supported action inside of the cluster. And the reason for that, in my perspective, is because there's a number of features and capabilities that rely on metrics. A horizontal pod autoscaler, vertical pod autoscaler, right? All of those things rely on metrics data in order to function. So if you disable that, then of course those things won't work. So yes, it's technically possible. It's not supported. It's not encouraged to do that. This person, I think what they were doing was doing some testing, and they were finding that the metric service, being the metric service, was collecting data, was doing its thing, and was adding a little bit of overhead when they were trying to maximize performance. And they wanted to just disable it to see what would happen. So the workaround in that case was simply to move all of the metrics resources, so Prometheus and Thanos and all the other stuff with that, and put that onto infrastructure nodes. And then at that point, it gets out of the way, and it's just the endpoints, the metrics endpoints that are still doing their thing. Yes, Alert Manager, very much so. It kind of needs to collect metrics to know when something is out of line. Nate is choosing a third-party SDN and install time decision, and how much complexity does it add to the install? Good question. So Generally, yes, it is an install time decision. I'm trying to think. I don't know of any off the top of my head where you can migrate after the fact. But considering we have a migration from OpenShift SDN to OVN Kubernetes, it wouldn't surprise me if it's possible. The complexity is really going to vary. So at a minimum, it's going to be something like, generate my OpenShift install, and then do a generate manifest, and then probably dump whatever the YAML files for deploying the SDN are into the manifest folder, and then continuing with a normal installation from there. I know that's how it works with NSX, the VMware NSX container plugin. And I believe that's also how it works with Calico. So the complexity is going to vary. I don't know if Flannel is a supported SDN, but that one's one of the quote unquote simpler ones. Maybe it's a little bit easier. Maybe it's just less stuff happening underneath the covers. I'm not quite sure there. But yeah, it shouldn't be too hard compared to many things, just an extra step at the beginning. All right, so I'm out of top of mind topics. I don't think I posted this link into the chat. Let me go ahead and do that real quick. Okay, so if anybody wants to take a look at that, that would be how you can forcefully disable the metrics service inside of the cluster. All right. So I built it up a little bit here at the beginning of our session here, talking about the performance add-on operator. And this is one that, like, the name is really intriguing. And, it sounds like it's this magic tool, like TuneD, right? I can use a TuneD profile and I can set all of these things inside of my cluster, and magically my performance is improved. But the performance add-on operator, it really takes it like a step or three further, in that you can modify effectively any and all of the low level, Linux Core OS settings and configurations inside of your cluster. So while it's incredibly powerful and I can do a lot of stuff inside of there, it's also just a teensy bit dangerous, right? We all like to live a little bit on the edge. Franck, I'm curious, and thank you very much for joining me today. This one, I know we've been planning it for a little bit, and I'm excited to learn more about this. So can we start with, like, what's the use case? Like, when, as the product manager for the performance add-on operator, what's the use case? When should customers, like, hey, I need to use this, versus I want to use it, versus you probably shouldn't use it?
Okay, so when do you want to use a performance add-on operator? So not necessarily for performance. It's really a very specific tuning that you need. So I'm a telco product manager, and telco is OpenShift on bare metal. And you need to have a very low-level tuning to make sure that you have the proper configuration end-to-end, so you can run what we call CNF, container. It's a cloud-native network function, which is basically, you want to make sure that you will really dedicate some resources to some containers. So you make sure that your container will never be preempted by the scheduler, by an interrupt. So this is where you want to use a performance add-on operator. Basically, fine-tuning to make sure that you can really dedicate resources, but not from a Kubernetes perspective, but also from an operating and system perspective, I would say. So that's number one. And on top of that, because performance add-on operator is an orchestrator of many underlying components, you have some very funny use cases, like you want to configure a kubelet parameter. And you can do that with, you can change any kubelet parameter on your cluster with performance add-on operator. You have other ways to do it also, but the thing is, as soon as you start to configure kubelet, you want to make sure that you have one source of kubelet configuration and not two components colliding in competition, and at the end you end up with something not coherent. But anyway, let's say that if you think that you need a TuneD profile, so first you need to know what's a TuneD profile. If you think you need to do some, I need to do some interrupt rebalancing, I care about NUMA locality, about my resources. And finally, potentially, I need to have a specific boot parameter on some worker node. This is where you should think about PAO. And when you start to use PAO, you have other tools that you used to potentially use to configure kubelet, and you should forget about them, because PAO becomes your front end for the whole configuration. And if you configure the one component at two places, guess what happens?
Yeah, I'm really glad that you brought that up because it was a question that I had in my mind as well, right? Because there's a tuned operator, there's machine config operator, and there's multiple ways of setting these, or sorry, the node tuning operator, not the tuned operator. So yeah, there's multiple ways of setting these things, and very much to your point, and I think it's a really good point of you don't want there to be conflicts. It's hard to, oh, I'm setting these things over here, I'm setting these things over here, I'm setting these things over here. Consolidate, standardize on one location and utilize that.
And it's even worse than that. It's you want also to configure cryo, very low level cryo parameter as well. And you want to be coherent between your cryo. Let's say you want some specific CPU in cryo configuration. You want the same in the boot parameter, and you want the same CPU list in the tuned profile.
Mm-hmm.
And if you do it manually, you may succeed, but you will need to rewrite basically PAO.
So why not use the tool that's there? Yeah, that's an interesting one. A lot of folks, especially I see chat about this all the time internally of, oh, I need to make this low level configuration change. And the kind of default answer has always been, machine config. Create a machine config, have it apply to the nodes, and then let it, basically you're laying out a file inside of the standard Linux file system to have it do that configuration. And is that always the best option? Maybe not.
So if this is something that if you're sure you're creating something new, and by the way, it won't be a low-level configuration, so maybe. But if you want to change the cryo configuration, you don't want to go via MCO. If you want to change the kubelet configuration, you don't want to go via MCO. So MCO is something like something that you would like to add rather than configure, I would say. Or you need to be very aware about all of the consequences about what you do. So yeah. So
Mm-hmm.
First thing first, can you use PAO and MCO? Yes, of course. We're always doing that. To set the same parameter? No. So this is where you need to have a deep and a good understanding about which parameter you want to set.
Yeah. So sorry to interrupt. And Nate brings up a good point here, which is it sounds like the performance addon operator is a good fit with specialized worker nodes. So he lists out here nodes with GPUs, special local storage. I think we can include, SRIOV or DPDK network adapters. Maybe special use case nodes. I'm thinking like, VRAN or something like that, where the real-time kernel is used.
Yes, indeed. So the performance addon operator is also helping to configure the real-time. No, so installing the real-time kernel is one thing, but then you need to have all of the associated boot parameter, the tuned profile, because when you install real-time, you want real determinism. You need to have a cryo config with or without hyperthreading, because you can be more or less soft on your real-time. Mm-hmm. So the best practice to be hard real-time is you disable hyperthreading, but when you want more throughput, you enable hyperthreading. So PAO can do that for you. One thing we didn't talk about is if you think about disabling hyperthreading, PAO could be a good fit. And some applications are faster when hyperthreading is disabled. And this is something that the application developer should know because his application, for instance, requires a big cache, right?
Yeah.
And when you have hyperthreading on, basically you divide your cache by 2.
Yeah, it's I'm an old school virtualization admin, and when we used to do sizing exercises, it's a hyper thread only counts as half of CPU when you're doing sizing. If I have 4 cores with hyperthreading turned on, so it's 8 virtual cores. But from a capacity perspective, I only want to count that as 6, the 4 full cores plus 2. Which I'm curious to see, or curious to know, with Intel's latest architectures, now they're coming out with efficiency cores, right? Performance cores, efficiency cores. I can only imagine if that makes it into the server hardware market, what that would possibly look like. That could make things really interesting.
Yeah, because on your server, you will have a pool of faster CPU.
Yeah.
So meaning the others are, and this is something that we work on upstream with Intel to enable it. So you will have some kind of first-class workload, very demanding, and so, okay, give me those CPUs. But if you start to be in this, if you want to consume them, you may have a very specific use case. It could be telco. So telco can be radio access network, as you said, and the most stringent in telco is VDU, as we call it, which is really close to the antenna, and then you have the CU, and then you have the core, and then you have others. Okay, so the real time is really for the really close to the tower, and the other use cases so far don't use real time, but use fine tuning, and with PAO. So if we step back just one thing, Kubernetes is about sharing and cloud native. Telco is about, okay, I want determinism. Yeah. So it's kind of the opposite, because either you dedicate, either you share, okay? So the idea is to find the recipe, the trade-off, to be able to collocate isolated workload and overcommitted workload. So we are globally efficient. So you have some kind of IT-like pods that can be overcommitted, running on hyperthreads, no problem. And you have the others that cannot suffer from an extra cache miss on the same platform. So this is something that is going to be one level beyond with Intel U CPU. And do you want this CPU to run more overcommitted workload or dedicated workload? I would say this is up to your application. But when you start to think about it, it's really application specific. I think that FSI, HPC, so it really depends on the workload. Okay, the workload designer should know if the workload designer is using kernel perf, Intel vTune to profile the application, look at CPU cycle, okay, you may want to use PAO. It really depends on...
I can imagine, AI, ML type workloads, all of that. So there's a couple of questions here. I'm actually going to ask them in the reverse order because I think, Nate, I'm going to use your question to ask Franck to do a demo on there. So PNUW asks, when doing .NET app modernization and basically having Windows Server, Windows containers in the cluster, does Performance Addon Operator work with those Windows nodes?
Nope.
I suspected as much. Machine config doesn't really work with Windows nodes either, but just in case.
No. So this is so we are Red Hat, and we provide a very low-level tuning of Red Hat Linux that can be packaged as a Core OS and shipped with OpenShift or OpenStack or other product, or as plain RHEL. And this is where our knowledge is, okay? And this is where we have a team pushing patches in the scheduler to make sure that, okay, nothing is going to disturb your workload, because you always have a piece of the kernel that want to run on all of the core at any time to gather some statistics, to do some LRU, this kind of thing. And this is what we want to tune to avoid. So basically, it's a lot on isolation and make sure that your application is not going to get any CPU cycle stolen. Yeah.
So I said I was going to use Nate's question to I kind of ask you to launch into a demo. So Nate's asking, with Performance Addon Operator, can you use labels, node selectors, to limit the nodes that the profiles are being applied to? And I suspect that if we look at how to deploy, how to use, how to apply the Performance Addon Operator to a cluster, that'll probably answer a lot of those questions.
Yes. So unfortunately, on my cluster, I only have 2 worker physical nodes. So they are all on they are on the same machine configure MCP. But if you have multiple MCP, basically you can have one PAO, one profile performance profile per MCP. So that's as many as you want. Okay. You even have inheritance, and you can do things which are very complicated on top of something complicated. So we can go through my setup and the various parameter if you want. The deployment of PAO is well documented,
yeah.
And the point is, what I'd like to talk more, if it's of interest of the audience, is it's about the use cases and what does it mean, this parameter, because you have two kinds of user. You have users which come from a very low level and discover Kubernetes, and they know what they want to do exactly, and say, okay, how do I translate my Linux configuration into an OpenShift configuration? And I can help these people to understand how to translate and go on top of the layers, because there are a lot of things in between that you need to configure that you are not aware of when you join the Kubernetes ecosystem, like Cryo, etc. And you have others, and you have the others which are more cloud native people trying to discover the low level stuff. So here, that's going to be an introduction, because at some point you need to read the, the programming guide is 900 pages, and you need to read it. Sorry.
Yeah, jumping back a little bit, when you said that you can have a performance, I'm going to call it a profile. I don't know if that's the right term, per machine config pool. That kind of makes sense, because you would assume that all of those nodes are going to have the same configuration, the same set of hardware, the same set of things. So that, to me, that is logical. I also like when you describe it as two groups of people like that, because I think I probably fall into that latter group, which is, okay, I need to deploy an application. Now I need to, tune it and figure it out. Whereas earlier, to your point earlier of, in theory, the developer, the application team should know exactly what they need. So they should be communicating that and kind of working from the bottom up.
Okay, so we can go through... So let me share my screen. So as you can see here, this is a cluster with 3 masters and 2 worker nodes. So these worker nodes are so they are Skylake, 72 CPU total. So you divide by 2. And you have the number of CPU, and you divide by 2, and this is per NUMA node. So if we go on one of these compute node, so CAT. So just for the audience, so those are reference machine from Intel. So my lab, and the code name was Wildcat Pass. So Wildcat Pass. So I've got 3 of these physical machines, and one of the machine is hosting my 3 virtual masters. So just for your information. And this machine, Cat and Pass, are connected back to back with cables. So I can do SRIOV and have a traffic generator on Cat and a CNF running on Pass, and push millions of packets per second and check that, okay, no cycle are stolen because no packets are missing. So, okay, so I don't have NumaTTL on this one. So what's important on this machine, and I'll be brief. So as you can see, I've got a lot of CPU, I've got hyperthreading, and I've got 2 NUMA nodes, plenty of memory. And what I want to show you is proc CMD line. So those are my boot parameters. So, and as you can see, I've got TuneD running with very specific core mask. I've got huge pages. I've got SystemD affinity. I've got IOMMU1. And if I go to my interrupt, RQ, default. So the default SMP affinity is it's not FFFF because I've got already pods running. So this is something that I will explain a bit. So if I tear down all of my pods, you will see that the mask of the core available to process interrupt is FFFFF. And as soon as I start an isolated pod, the CPU is not available for interrupt anymore. So they are pulled away. So this is thanks to the TuneD profile that is applied. So this is what you have on the, so this is my physical worker node. So now back to my, so let's have a look at my performance profile. So I can do many things here. I'll be quick and then we can go back on it. But so my performance profile, his name is DPDK ready. As I can say, so I want to configure some ccTL which are unsafe. So because my CNF wants to be able not to accept router advertisement IPv6. So okay, so I can do that with PAO with this syntax. So with this kubelet, so it's called experimental because we have hope that at some point we are going to be able to have a hierarchical tree like RC.1, RC.2 for kubelet, but this is a long shot. And even if it's experimental, here it's fully supported by our teams and for our customers. So here, this is my CPU topology. So I've got a dual socket system with all of these CPU on socket. So this is socket 0, this is socket 1, and the siblings are this way, so 036. So that guy is sibling with that guy. I've got hyperthreading on. And I've split my CPU between reserved and isolated. So reserved, if you see this one, so here I've chosen to let 2 CPU per NUMA node. That's a lot. Usually you just let 1. Okay, just it's for the sake of being. So it's to do some R&D. So that's my lab. So one thing is, and those are isolated. So when you look at isolated, you think, okay, they're isolated, so I cannot use them. And this is where sometimes the labeling is misleading. These CPU are candidate to be isolated, but until a pod is isolated, they are going to run whatever needs to be run. So this is what's a little tricky. Isolated is not really isolated, and this is a Kubernetes syntax. This is not a PAO syntax. So then I configure the huge pages. So 64 in total, so 32. This is how it's working. So 1 gig huge pages. I don't like to make huge pages. Why do we use huge pages, by the way? Do you know?
So if you're asking me,
Yeah.
it would be purely a guess, and that is because we want to avoid additional allocations in the memory map. So it's one big chunk instead of a bunch of little chunks.
So almost. It's because you want to avoid the cost of a TLB miss. With huge pages, you don't have a TLB miss. And the TLB miss is one of the most expensive things that can happen to you in terms of CPU cycle. It could be like, because you have to walk on the on the page table. The worst case scenario is you have 4 touch, so you can have like 4 cache misses in a row.
And that TLB, is that related to NUMA or is that something else?
That's per CPU. Each and every core, if you want, they have their TLB, which is a little cache of resolution of virtual to physical. And when you have 1 gig, your resolution is already done for all. You don't need to do some physical to virtual resolution.
And just out of curiosity, because I'm learning things, is there rhyme or reason to sizing those huge pages?
So this is a hardware constraint. So the hardware, the Intel CPU that I'm running on, offer 2 meg huge pages or 1 gig.
Got it.
So with 2 meg, it's not enough for the size of the application that we run usually, because CNF are kind of like it's very common to have like 32 gig process. So you want to lock off all of your memory into huge pages, so you have zero cache miss. Because again, in CNF, in Telco, the unit of count is how many CPU cycle per packet. So to process 1 packet, how many CPU cycles I am going to consume?
And Thomas asks, TLB, Tango Lima Bravo, is that the correct acronym?
So that's a translation look-aside buffer. So it's when you have you know that your virtual memory. So it's all back to the concept of physical memory and virtual memory. So your CPU manage virtual memory, but it's backed by physical memory, and you need to do the mapping, right? And to do the mapping, you have page tables. And every time you go, because you want to resolve a physical address to virtual address, or you may have a page which is missing. So you know, when you go through the memory, so one page is missing, so you allocate the memory on the fly. Yeah. With 1 gig huge pages, your 1 gig are set and locked in memory. So it's not going to go away to be swapped out, for instance. It's going to stay in memory. So basically, you're super fast, but
got it.
But you don't share.
This is all interesting to me. You know, I've had some awareness of NUMA and kind of the, you know, when folks would want to use it. Again, I'm an old virtualization administrator, so you know, we would have workloads that need, you know, NUMA awareness, that need to be penned to a specific NUMA node, you know, for that performance. But learning the details, this is all super interesting to me. I also think it helps to understand when it is and isn't applicable, because there is such a thing as overtuning too, right?
Oh yes, yes. And this is what I try to avoid, because then when there is a parameter I don't understand, I just don't set it.
Yeah, I've always, it's one of those things of, and I know you're going through and you're setting a whole bunch of things inside of here. I always tell people change one thing at a time, so that way you know you know if it changed positive or negative, right? You know what caused that change.
Yes, and every time you change a PAO parameter, often you need to reboot your worker node, because it's translated. A lot of these parameters are translated to boot parameter, kernel parameter, plus other parameters. So reboot is necessary. So it can be time consuming.
Yep. And Nate, you're correct there, right? It's huge pages, avoid the TLB misses.
Exactly. And TLB misses is what you want to avoid, because this is one of the most costly event that you can have, because you're executing code and then you access to memory and boom, you have to walk through the pages, and you have like 5 cache misses, 4 cache misses, worst case. So because we have no virtualization, with virtualization, it's even worse, because you can have like up to 16. So, so you want to have huge pages. And about single NUMA. So Kubernetes permit to have, so you have various policies with the topology manager. And you can ask the topology manager to say, okay, my pod will have all of its resources on the same NUMA node. What are the resources? Memory, devices, CPU. Why that? Because every time you cross NUMA, your performance is going to suffer, but suffer big time. So if your memory is on NUMA node 0 and your CPU is on NUMA node 1, you need to cross the bus between the 2 sockets to access to your memory. Same for your device. So it's so because generation after generation, so the chip vendor, they have done a great work, and the throughput is okay, but still you have latency penalty, and latency matters, because it's not only how many packets per second I can get in and out of my network application, it's also the latency. In particular, when we think about 5G, we have a very limited quota in terms of time to get through the whole RAN to the roll core. So a packet needs to be processed and sent out on the wire as soon as possible, because your quota is ridiculous compared to 4G. So single NUMA, it's really locality between memory, CPU, and devices. Devices being, in the case that primarily network interface, but it can be GPU, it can be a look-aside accelerator like a Fourier transform accelerator, or a crypto engine.
Yeah, I know even some high-performance databases benefit from like NUMA awareness and all that. And PNUW, thank you for linking the documentation there. That's very helpful. So Frank, I feel like I've distracted you long enough. I want to make sure that you have time to finish.
No, that's fine. And then you have all in the documentation, and the last part is those comments are my comments and they're related to my platform. So, because next week I'm on PTO, for instance, when I come back from PTO, say, okay, why did I put this parameter? Okay. So one thing which is very important is in PAO, you want to make sure that all CPU are listed here. Because if you forget one CPU, Kubernetes is going to schedule workload on it, and there will be absolutely no tuning applied. And it can, and Kubernetes may schedule an isolated pod with containers that require isolation, and it's not going to be isolated. So you want to make sure that all of your core are isolated or reserved, no CPU left behind. And again, isolated does not mean isolated. It's candidate to run isolated workload. And as I can show you by killing my pod after, you will see that my interrupt mask is going to be increased to cover all of the CPU as soon as my isolated pod will be destroyed. So it's really dynamic. So basically, with PAO, you have specific boot parameter, but from a Kubernetes perspective, until you start pods with dedicated resources, you can use it as a regular over-committed node.
And a quick follow-on question here from Nate. Are TLBs, are they a CPU feature or a kernel feature?
It's a CPU feature. It's built in the silicon.
Okay.
And finally, something I'm going to show you on my worker node, which are related to interrupt. So why am I talking so much about interrupt? So interrupt are asynchronous events that are going to trigger kernel activity to process packets typically, or to do I/O when you have interrupt related to disk. And every time you run the kernel, well, you don't run your application. So you still cycle from an application that needs 100% of the available CPU. So that's why you want to get your interrupt away. And this net is something which is interesting because by default, when you start a Linux machine, for a lot of drivers, you have one interrupt per available CPU. So in my case, I've got 72 CPU. So for each and every network card, I've got like 72 interrupt vectors. So that's a lot. And the point is, if you want to, so it's a little complex, but if you want to avoid interrupt on an isolated CPU, you have a hardware constraint. You want to make sure that you can pin this interrupt to a CPU which is not isolated, but you have a constraint which is on a given CPU, you cannot put more than 224 interrupt because that's a hardware, that's part of the silicon. So you have a limit at 255, but you have 32 already taken, so 224. So if you end up with 600 interrupt on your system, it means that you need at least like 3 CPU not isolated to handle all of the interrupt, because if not, the hardware is not going to tell you, and the CPU and one of the CPU is going to process the interrupt because it's going to get the interrupt vector, and you will not see. That's called interrupt overspilling, right? So you want to pack your interrupt on 2 CPU, but you have too many interrupt that the 2 CPU can not process, but accept in their interrupt table. So that's why here we have this option in Performance Addon Operator to say, okay, I'm going to have as many interrupt vector as my reserved core. And the rationale is the reserved core are here to do non-container workload, if you want, like running systemd, OVS, sorry, etc. And this one can be interrupted. So, and also, you don't want to have only one interrupt per NIC because you want to do some multi-threading, because if at some point you have a boost of network traffic, you want to be able to spread the load on multiple CPU. So basically, with user networking equal true, you are going to spread your interrupt on this reserved CPU at least, because you're going to spread your interrupt on more CPU, basically all the reserve plus all the CPU which are not running isolated pods. Okay, I'm going fast. It's complicated.
Well, and just to be clear, so effectively without having those CPUs reserved for interrupts, it has kind of two effects, right? So one is it literally interrupts the processing of the application, which potentially slows down the application. But two, because you're having to rely on the CPU scheduler across all of those already busy CPUs with the application, it can potentially slow down things like network throughput. So if you're pushing 100 gigabit or something like that, and your CPUs are running near capacity, suddenly you're not able to hit that throughput, that you would like to. Instead, it's something lower.
Exactly. So very briefly, so this is my performance profile now. Let's have a look at my pod descriptor. So in Telco, we have a very popular application, which is the DPDK test program named TestPMD. And I've got a lot of annotation here, but what matters in this container? It's dedicated resources, right? So you have east and west. Sorry, because what's running is not what you see. I've got too many machines.
I have that issue as well.
So this is the right one. So what's interesting here is, for instance, this is a CCTL that you have seen, and I'm setting the value to 0, and I can do that because I've put that in PAO, so it's a safe. And here, so I'm having 4 CPU, 2 pages of 1 gig of huge pages, and 1 gig of generic memory, because you always need a bit memory. So that's basically what I have, plus 2 SRIOV interfaces. And I've got some extra annotations here. So very important, you need to put the runtime class, which is the name of the performance profile that you can get by following the documentation. So what do I do? What I say is interrupt load balancing disable. So I disabled so this pod. What I'm saying is when you start this pod, please move all interrupts away from my CPU. Okay, so this pod has 4 CPU, no interrupt on these 4 CPU. So in the former version of OpenShift, before 4.7, by default, that was a general option, but now it's opt-out. So each and every pod needs to say, okay, I want to get the interrupt out. Then this one is, we have a bug in Cryo that is going to be fixed upstream at some point, but until this bug is fixed, you need to put this quota disabled, because even if you request a complete CPU, Cryo is going to CPU throttle your workload. So this is bad. So you need to put this option. And finally, you can also unplug the CFS, the Linux Fair Scheduler. So here I've got 4 CPU, 2 cores, 4 hyperthreads. So when I start an application, by default, the Linux scheduler is going to try to reschedule on one of the 4 CPU and make it the best to spread the load. So we want to disable this behavior most of the time because we want to avoid extra kernel activity. So here, what you said to the kernel, so basically you disable the fair scheduler. So once a task is started on one CPU, it's going to stay on this CPU until it dies. But the application on top can do via task set the pinning on another CPU. So it's not like, so the Linux scheduler is not going to move the application to another CPU, but if the application wants to, it's possible. Also, the application can start, yeah. So this is what it's going to do. And this is the behavior that you had for the people coming from the old time when you had isol CPU domain as a boot parameter. So that's the exact thing. You had a CFS disabling. So this is a way to get this feature. So let's see, get pods. So I've got my TestPMD pod running. It's running on wild. So on my machine pass. So And have you seen before debug? So let's go on pass.
Mm-hmm.
So if I go on my machine path, you will see that the /proc. So I've got some CPU, exactly 4, because C is 1100. So I've got 4 CPU which have been taken out. So I'll be brief, but what I'm going to do to show you this is you see delete pod EMD. I'm killing the pod, back to pass. So the pod is no more there. Proc ERQ. And as you see, any CPU can take interrupt again. So every time you boot an isolated pod with a proper annotation, this mask will be updated and all interrupt of the system are going to be moved of the CPU which have been allocated to this pod. So these CPU are really isolated from kernel isolation, of course. They are isolated from other pods from Kubernetes. So, but this is really the low level of things. People don't usually think that, okay, I've got a kernel running and kernel can preempt my userland.
I'm just catching up because I was responding to a chat message. Marifet, I don't know whether or not Alert Manager supports SNMP traps as a destination. So I'll have to check with one of our SMEs and get back to you on that. So you can tune in 2 weeks. We'll talk about it at the top of the stream during the top of mine. Or feel free to send me an email, andrew.sullivan@redhat.com. And as soon as I can get that answer out to you. I'll also include it in the blog post that follows each one of these streams as well. So keep an eye on cloud.redhat.com/blog. Mark, curious to know about hyperthreading for an OpenShift cluster running in virtual machines. Seems to make sense to set the VMs to use 2 threads on the virtual CPUs. So that's an interesting question in that. So everything that you've talked about here is effectively OpenShift running on bare metal and having access to directly and natively control everything about that system. Does this still apply if we're running in virtual machines? Do you need to configure things at the hypervisor level to pass through, or?
No, because when you run in a virtual machine, you run on a virtual server. A server is a server. So this server is exposing you hyperthreads or not. So it depends on how Linux is configured and the hypervisor is configured to show you CPU which are number 0, 1, 2, 3, 4 or something a little more fancy, showing you up a NUMA topology and hyperthreading. So basically, what's a VM? It's just like you enable VTX and you run the same thing. So of course, and by the way, we do that on OpenShift, on OpenStack. We have a complete end-to-end tuning for telco, so it applies. So I did a demo of this before COVID in Denver. So if you search for my name, Open Infra Summit Denver, we did a demo live on stage. That was Kubernetes on OpenStack end-to-end with all of the tuning manually applied without PAO. And I'm glad we have PAO now.
Speaking of Open Infra Summit, I think we missed it, but I think yesterday was the cutoff for paper submissions, session submissions. I think it was yesterday at like 5 p.m. Central Time. So unfortunately, if anybody wanted to submit a session, we missed that one. Mark and Rev, I noticed that the recommended setting for x86 architecture is 1 thread per core /CPU. So that's going to vary. So I think what you're asking is, if the physical server has hyperthreading enabled, the hypervisor is taking advantage of that. Should you basically take advantage or use those hyperthread cores for your OpenShift nodes? And the answer to that is maybe. Right? It'll depend on a bunch of different things in your application. I always, encourage people to or remind people that oversubscription at the hypervisor level can significantly affect performance at the OpenShift level. So, in VMware, there's the performance latency setting where it basically reserves all of the resources. In Rev, there's things with IO threads as well as CPU reservations and threads per CPU, as you were calling out there, that can all affect that performance. So if you are seeing performance degradation in OpenShift as a whole, or most especially the control plane nodes, utilize those hypervisor features to kind of dedicate it or give it more priority inside of the resources that it has. Yeah, built our cluster before the Rev integrations. So I don't think the Red Hat virtualization VMs are using anything special. So please reach out to me. We have the Rev engineering team. They're really good about answering those questions, and they're really curious about that stuff. So, and I know the product manager would be very interested in any use cases or concerns you have there. So Mark, feel free to send me an email, andrew.sullivan@redhat.com. I posted it just before your chats there. Thank you, Stephanie, for putting my contact information up there. That works too. Excuse me. So I know we're about 6 minutes over according to my clock here. I don't want to intrude into your evening. I know over in France it's getting later in the day, and I definitely don't want to interrupt your off time, your family time, Frank. So if anybody has any last questions, please go ahead and submit those into the chat. We'll address those as they come in. Is there anything else you want to cover, to talk about? I'm digging through our shared document here, looking to see if there's.
So I recommend people to read the PAO documentation. The page is really long. It reminds me of the TCP code of the BSD stack, because it's one file with everything in, all the TCP stack in one file. So it's pretty the same size. But everything is in there. And at the bottom, you will have something that, when people talk about a lot about DevOps, but at the end, what the best practice is, when you do something, you want to test that what you get is what you expect. So when people use PAO, you need to think about, okay, how am I going to make sure that I've got the isolation I want? And in this page, you will have some handy tool explaining you, okay, how to make sure that, okay, if something was wrong, you run a tool and you will see, I see CPU preemption, that's bad. If this is what you want to see, for instance. Mm-hmm. So it's not only about understanding, you need to think about how you're going to test it, and we have great tools and linked into the product page.
All right. Well, thank you so much for joining today. This has been, like I said, it's been a really interesting one, and I've learned a lot about the lower level performance tuning, performance capabilities, stuff that I've had, I'm going to say, the luxury of not having to pay attention to over the last few years, but nevertheless, it's still really interesting to me. Again, it punches all those buttons for me, the nerd knob, so to speak. For our audience, thank you for joining us today. We really do appreciate it. Again, if you have any questions, if there's anything that comes to mind after you have watched the stream, or if you're watching it not live, feel free to reach out. You can reach me on social media at PracticalAndrew on Twitter, or via email, andrew.sullivan@redhat.com. And of course, I'm more than happy to bring Frank into the conversation if needed, to help answer those questions. One last reminder, we won't have a stream next week because of the What's New presentation. Be sure to tune into that. In 2 weeks, we'll be back. Johnny will be back off of PTO, so it'll be the whole crew here. Stephanie in the background, thank you so much for all of your help today and posting links and keeping us on point. And with that, I hope everybody has a great rest of their week, great weekend, and stay safe out there.
Thank you.